In this video, I'm going to go over some practice questions on the incline plane. So I've been given a first question, a 200 newtons wagon, which is to be pulled up a 30-degree incline at a constant speed. Okay, so this word is up here. It's supposed to be pulled up at a constant speed. So I want to find how large a force that is needed if the coefficient of kinetic friction is 0.25. So we want to pull this thing up at constant speed. So what should be the force for us to be able to do so? So we need to determine the net forces in the x because we want to pull it up. So the net force in the x is going to be given by the forward force. The force which is going in the direction of the acceleration is the applied force F. And then notice that we've been given kinetic friction. That means we have got friction in the down, so I've got kinetic friction. Now for anything that is on an incline, there is always Fg. There is always a force that pulls it downwards, the force due to the mass, the x component, or the mass which is on the incline. So what we are going to have is force is the only one which is going to the positive direction, and then the others are going to the negative, and so they are going to subtract. We have got Fk and also Fg. Okay, but we are talking of constant speed. So whenever we have got constant speed, whenever we hear of constant speed, that means acceleration is 0. So this is giving us mass times acceleration is equal to force minus Fk is given by mu k mg cos theta, and then Fg is given by mg sine theta. So if you can't know where these equations are coming from, we have got a video you can just scroll and check out on where these equations come from. So we know that acceleration is 0, so 0 times mass will give us a 0, so this will be 0 is equal to force minus mu k we've been given as 0.25. the mass of the system has been given as, okay, we've been given the weight. So this portion which is here, mass times gravity, is what gives us the weight. So mg will give us 200, and then cos, the angle of incline is 30 degrees, and then minus mass times gravity, same, this portion here is going to give us the weight. The weight we've been given as 200 newtons, and then sine the angle theta, okay, 30 degrees. So we go on and punch on our calculators. So this is going to give 0 is equal to force minus, so I've got 0.25 multiplied by 200, and then cos 30 degrees. So what I'm finding is 43.30, and then minus 200 sine 30 degrees. So what I'm finding is 100. So this will give us 0 is equal to F. So if we work out these which are here, negative 43.3 minus 100, okay, 43.3. So that is giving me negative 143.3. So if we take this side, we're going to have 143.3 is equal to force. So therefore the applied force, okay, the minimum force that we need to apply for this thing to move at constant speed should be 143.3 newtons. Okay, so there will be no acceleration, it is going to move at constant speed. Alright, let's go to the next question. So we've been given a 20 kg box, and then we've been told that it slides down a 30-degree incline. So we've been given the coefficient of kinetic friction as 0.30. We want to determine the acceleration. Okay, so a 20 kg box is here, we can see it on an incline, and then they've said mu k on the box is 0.30. So let's say the acceleration is going down here, that is the direction of the acceleration. So because we've been given, not remember always to anything that is on an incline, there's always a force that will be pulling it down. So there is Fg pulling it down here. Now if there is Fg, that means that is the force that will be pulling it down, because we don't have any applied force here. Now notice that we have got kinetic friction. Kinetic friction works against the friction which is causing an kinetic friction works against a force which is causing an acceleration. So kinetic friction is going to work in the opposite direction. So we are going to say the net force in this case in the x will be given by the force producing an acceleration is Fg. And then we're going to remove a force reducing the acceleration, in this case is Fk. So net force is given by mass times acceleration, and that will be equal to Fg is given by mg sine theta, and then Fk is given by mu k mg cos theta. So again, go on and substitute our values. The mass has been given. Anyway, it doesn't even depend on the mass because the masses are going to cancel out like that. So we're going to remain with acceleration is equal to g sine theta subtract mu k cos theta. So the acceleration just depends on the angle of the incline and also the coefficient of kinetic friction. So g is 9.8, and then sine the angle theta is 30, and then minus mu k, which is 0.30 cos 30 degrees. So punching on our calculator, 9.8 sine 30 degrees, so that has given me 4.9, and then minus 0.30 k cos 30 degrees, that has given me 0.2598 k. So that was 9.8 sine 30. Okay, 4.9. So from 4.9 we are removing 0.2598. So my acceleration in this case is giving me 4.64 meters per second squared. So the reason as to why this acceleration is positive is because we are taking the down motion as positive. So if we took going up as positive, this acceleration would have been negative because it is going in the negative x. So the way we get this is we are going to get this as the positive x-axis, this as the positive y-axis. So going down means we are going to the negative. So we expected the acceleration to be negative if we counted the motion to be going up, but we are taking motion to be going down. So that's why the acceleration is also positive in that manner. So I've been given another question. When a force of 500 newtons, so we've been given 500 newtons here, is applied at 40 degrees above the horizontal to a 25 kg box as shown. The acceleration of the box is 0.75 meters per second. Now I want to determine the coefficient of kinetic friction between the box and the incline. So the first thing is we need to understand what force is acting on this block. So this block, the first force which is there is the weight force going down, which is mg. The other force that we have is the force which goes perpendicular to the surface, which is the normal force making 90 degrees to the surface. If we extend the normal force, what we are going to have is this. So this angle here will be the same as this angle. So this will also be 40. Okay. And then if we join this to form a right angle triangle here, this will be our x. So this we can see the x is parallel to Fg. So Fg is a force which always pulls masses on an incline downwards. Okay, so there will always be a force to pull it downwards like that. And then we have got this one, y. This y is cancelling the upward forces. Now consider, because the motion is going up. So if motion is going up, what we have here is because we've been given, we want to find the coefficient of kinetic friction. That means we have got friction in this our case. So friction always goes in the direction that opposes motion. So in this case, motion is going up. So friction is going to be pointed down. Okay. So friction is going to be acting on this block in the down direction. That will be Fk. Now notice that this force that we have applied, we have not applied it straight, but we have applied it at an angle. So the component of the force that is going to make this mass to go forward is the x component. So this weight is going, that force is going to be distributed into the y component downward. That will be called Fy, and also the forward component, which will be called Fx. Okay, so that will be how it's going to be. So in this case, I don't know if this is looking clear. Let me just make it much clearer so we see what is happening here. So we've already shown all the forces acting on this diagram. So now let me show them. Those forces which are acting in the up direction, we have got the normal force, and then we already found we have got y here, the y component of the weight, this weight which is here. Okay, and then those forces acting in the x, we found that we have got first Fx. So let me put it here. We have got Fx, that is the x component of this force which has been given at the 500 newtons. And then we have got Fg, which is taking this thing downwards, because Fg always lies things down. And then because we've got kinetic friction, this friction is going to be reducing motion, or to be taking motion downwards like that. Okay, we've also discovered that this same applied force has got also the y component. So there's also the y component of the applied force. Now it's going down, so it's going to go in that manner, that is applied force in the y direction. Now let's find the net forces first in Vy. So the net forces in Vy, let's get those forces which are going down first. Okay, let's get those which are going in the positive y. Positive y means going up. So you can see we only have the normal force going up. Okay, so that will be normal force, and then remove all the forces going down. We've got y and we've got Fy. So the net force, because this thing is not moving up, it's not flying up, it's not coming down, it's not moving in the y, so the net force is going to be 0. So that will be called normal force minus y. The y component of the force is given by, remember we have got the weight force here, which is our mg. Okay, and then we've got the angle here. So we can see that this y to this angle, which we can see, it is adjacent, so we use cos for that y. So our y is given by mg cos theta. And then our Fy, our applied force in the y direction. If we come here on this portion, notice that y is going to be in this way. So it is opposite to the angle that we've been given here. And so we are going to use sine. So Fy is applied force sine the angle theta. So this is going to give us 0 is equal to normal force minus the mass we've been given as 25, and then gravitational pull is 9.8, and then cos this theta we are using for y is the angle of the incline, that is 40, and then minus applied force is 500 sine this theta we are using is the angle at which applied force has been given, that is 40 degrees also. So if it was different, please get the difference. So this one is for the applied force, this theta here is for the incline. Okay, so that is going to give us n minus, if we press on our calculators, we've got 25 multiplied by 9.8 and then multiplied by cos 40. So that is giving me 187.68, and then we subtract 500 sin 40. So that is giving me 321.39. So this will give me 0 is equal to n. So if we do subtract these two, what we're going to get is okay. So we're saying negative 187.68 minus 321.39. So what I'm getting is negative 830.4676. So if I take this the other side, what I'm going to find is normal force. Normal force is going to remain, and then this one is become positive 830.4676 newtons. So that will be the normal force. Now let's go to the y, because we want to determine the value for the coefficient of kinetic friction. I mean, let's go to the x motion. So the net force in the x, what force is making this thing to accelerate? It is only Fx. And then the others, notice that they are going in the opposite direction, Fg and Fk. So we've got Fg and also Fk. So the net force index is given by mass times acceleration because it is moving, and that will be equal to Fx. The applied force in the x is given by force cos theta. Okay, that is because if we check on the diagram, applied force in the x is going in this manner. So to this angle it is adjacent. I don't know if we can be able to see that. Okay, and then minus our Fg, which is given by mg sine theta, and then our Fk. Let me just write Fk at this point. So our mass is 25, and then our acceleration is, we've been given as 0.7. okay, I left a squared there. That is 0.75 meters per second squared. That's the acceleration. And then the applied force F is 500 cos the angle, which is 40. Okay, which is 40, and then minus our mg mass, which is 25, g, which is 9.8, and then sine the angle is also 40, and then minus Fk. So this will give us 25 multiplied by 0.75. I'm finding 18.75, and that will be equal to 500 cos 40. So this angle here, which we can see clearly, is 40. Let me just write it properly. Okay, this is 40. So 500 cos 40 is giving me 383.02, and then minus 25 multiplied by 9.8, and then that answer sine 40, that is giving me 157.48, then minus Fk. So what I'm going to do is I'm going to get this Fk and take it the other side of the equation. It becomes positive Fk, and then here what is going to remain is 383.02 minus 157.48, and then minus 18.75. So this 18.75, I've taken it the other side. So we have got 383.02 minus 157.48 minus 18.75. So my Fk here I'm finding is 206.787 newtons. Okay, now notice that we want to find mu k, the coefficient of kinetic friction. So kinetic friction itself is given by coefficient of kinetic friction times normal force. So kinetic friction we have found as 206.787, and then we don't know the coefficient of kinetic friction. The normal force we already calculated as, okay, the normal force we calculated 830.4676. Alright, so that is what we calculated. So if we divide now, we are going to divide both sides by 830.4676, even this side by 830.4678. So we see what we are going to find as mu k. So that is 206.787 divided by 830.4678. What I'm finding is 0.249. So it has got no unit. The coefficient of kinetic friction has got no unit. Okay, so let's hope what we've done is just right. Let me just confirm again. So let's keep this equation in mind, the value for Fk. Okay, I just want us to double check what we have done. I just want to confirm again the normal force that we found. So we said the normal force we calculated from the forces in the y. The forces in the y, first the one which is giving us a positive is the normal force, so that is normal force, and then we remove those which are going down. The first one is y, and then the second one is fy. Okay, so we say this is going to be 0 because it's not moving up or down. And then we don't know the normal force, and then we subtract minus y. How do we find this y? So y is the y component of the weight, and y component we said we are going to use cos because the angle which is here, this side is adjacent to that angle. Okay, so y is given by mg cos theta, and then minus our fy. Notice that it was opposite to the side, so that's why we said we are going to use f and then sine theta. Okay, so we are saying if we have normal force, we are going to take these other forces the other side. So normal force is going to be mg cos theta plus f sine theta. So the normal force is going to give me mg, our mass is 25, and then g is 9.8, and then cos the angle is 40, and then plus our force is 500, sine the angle is 40. Okay, so if we press on the calculator, 25 multiplied by 9.8 and then cos 40, and then plus 500 sine 40 also. So the value I'm getting, I noticed that I had used 30 degrees instead of 40 when I was punching on the calculator. That was supposed to be 509.07. Okay, so that if we come, we say kinetic friction is given by mu k times normal force. So the kinetic friction, we already determined the value here as 206.787, and that will be equal to mu k times the normal force, which is 509.07. So if we want to find mu k, we divide 206.787 by 509.07. So the answer is supposed to give us 0.41. Alright, so I didn't press the right value on the calculator. That's why the answer, I was doubting it. Okay, we've been given another problem here. Two masses are held together by an inextensible cord as shown. If the coefficient of sliding friction between the boxes and the incline is 0.31. So we've been given that coefficient of sliding friction. So whenever we're talking of sliding, that is movement. So we're talking of kinetic friction is 0.31. Now I want to determine the acceleration of the system at the tension in the cord. Now notice that this thing is going to move in that manner. Okay, that will be the direction of the acceleration. But what will be pushing this thing down? So that is Fg. Anything that is on an incline will always have that Fg. And what will be reducing motion for this mass which is here is, we have got first the tension in the cord, because this mass which is here will be reducing motion for this one. That is through the cord, through the connection which we have. So tension will be reducing the motion. Now notice that we've been also given kinetic friction. So there's also friction which will be reducing the motion here, the kinetic friction. So talking about this one alone, if we come to the net forces in the x, the one going in the direction of the force is, the direction of the acceleration is Fg. The other one, Fk, and tension, they are reducing motion. So the net force in the x will be given by mass times acceleration, and that will be equal to Fg is given by mg sine theta. Fk is given by mu k mg cos theta, and then minus the tension. The mass we've been given here is, so we're starting with the first 20 kg mass, so 20 times the acceleration is equal to 20, G is 9.8, and then sine the angle of incline is 35, and then subtract mu k we've been given as 0.31 times the mass, which is 20, times gravitation pull, which is 9.8, and then cos the angle again is 35, minus tension. So this will give us 20A is equal to, so we press that on the calculator, 20 times 9.8, and then times sine 35. So that gives me a value of 112.42. And then we have got minus 0.3 times 20 times 9.8 times cos 35. So what I'm getting there is 48.166, and then minus the tension. So if I work out these two, and then let me take the tension over the other side, so what I'll find is tension plus 20A is equal to, so I've got 112.42 minus 48.166. So what I'm finding there is 64.25. So this will be our first equation with two unknowns. We don't know the acceleration, we don't know the tension. So let's come to this mass which is here. So because the whole of this system which we have here has got friction, that means the force that will be pulling our 30 kg mass forward is the tension in the rope, because that's the one where we are connecting to this thing which is moving. And then because there's friction, there will be friction reducing motion here. So these are the only two forces which are acting in the x. So the net force therefore in the x will be given by the one which is going in the direction of the acceleration is tension, and then we've got Fk going in the opposite direction. So that will be given by mass times acceleration, and that will be tension minus kinetic friction is given by mu k times normal force. Now in this case, this was the normal force for something that is on an incline, something that is in that way. Something that is straight like this, normal force is the force that acts upwards. In this case, the normal force cancels with the weight. So in this case, something that is on a level place like that, the normal force is given by mass times gravity. Okay, that will be mg. Our mass is 30, our acceleration we don't know, the tension we also don't know, minus mu k we know is 0.31, and then what else do we know? The mass here is 30, and then g is 9.8. Okay, so this will give us 30A is equal to T minus, so 0.31 multiplied by 30 multiplied by 9.8. What I'm finding there is 91.14. So what I can do is I can take this, the other side becomes positive, so that will be 30A is equal to, sorry, not equal to, we have taken the other thing the other side, so 30A plus 91.14, and that will be equal to the tension. So we can see tension here. So in this equation where there is tension, we are going to substitute 30A plus 91.14. So that is going to give us 30A plus 91.14 is equal to, okay, I've just substituted where there is tension, so just this T is where I've put this. So that is where I've put this. Remember, we've got also the 20A there. Okay, plus 20A, and that is going to be equal to 64.25. So what I can do is I can take this one that side, so I'll remain with 30A plus 20A, which will give me 50A, and that will be equal to the 64.25. If 91.14 go the other side, it becomes negative. So it becomes 64.25 minus 91.14, which will give me negative 26.89. So therefore the acceleration in this case is giving me negative 26.89 divided by 50. So that is giving negative 0.53 0.78 meters per second squared. So that would be the acceleration, which we can also write as the acceleration is negative 0.538 meters per second squared. Now let's determine the tension. We can use any of the equations. We have got two equations which have got tension in them. So we can pick the second one or the first one. So let me just use this one, which is here. So tension is equal to 30A plus 91.14. So that will give me 30. The acceleration we've determined as negative 0.538 and then plus 91.4. So 30 multiplied by negative 0.53 and then plus 91.4.14, sorry. So I left a 1 there. So that is giving me a tension of 75 newtons. So that would be the tension for that problem. Alright. So another question given here. A 25 kg box slides on a rough incline with a coefficient of static friction of 0.26. What is the minimum force to be applied if the box was to slide? So we want to determine the minimum force that we can apply to this box if it were to slide upwards. So what can be the applied force? Now we've been given the coefficient of static friction, mu s, as 0.26. So static friction is a friction which we need to overcome for something to start moving. As long as we apply any force which is smaller than the static friction, our object will not be able to move. So we want to apply a force upwards for this thing to move. Remember, there is always a force Fg which is acting downwards on something on an incline. And then because we're talking of friction, this static friction is preventing also this thing from starting to move up. So we also have static friction. So this force has to overcome these two, okay, for it to start moving, for the mass to start moving. So we're going to say the net force in Vx is going to be given by, we want it to go forward, so this will be the positive one, applied force, and then minus, remove those which are reducing motion. We've got Fg and also Fs. So because we are saying just to start moving, we want the minimum force to be applied if the box was to slide upwards. Minimum means what just needs to start moving. Okay, at this point it has not started moving. We just want so that if we exceed that value, then it is going to move up. So the acceleration is still 0, it is not moving. Okay, so net force is going to be 0. So that if we apply any force just greater than the value we are going to calculate, then that thing will start moving. So that will be applied force minus Fg is given by mg sine theta. And then Fs, static friction, is always less than or equal to mu s times normal force. So we are going to put mu s there. Now normal force in this case, normal force for something that is on an incline like this is given by mg cos theta. So we're going to put mg cos theta there. So this will give us 0 is equal to force minus our mass is 25, gravitational pull is 9.8, and then sine the angle is 25 minus mu s, which we've been given as 0.26, then times the mass, which is 25, g is 9.8, and then cos the angle, which is 25. Okay, so this will give us 0 is equal to f minus, so 25 multiplied by 9.8 multiplied by sine 25, that is giving a value of, okay, that is giving me a value of 103.54, then minus 0.26 multiplied by 25 multiplied by cos 25. I'm finding a value of 5.89. I've left out f here, so I'm supposed to put that f there. So we are saying 0 is equal to f minus, okay, so this part is what has given me this value here. So this will give us 0 is equal to F minus 103.54 plus 5 points. So we are subtracting them. Both of them are negative, so it's the same as adding them, just that they'll give us a negative value. So what I'm finding there is 109.43. So if we take it the other side, we're going to remain with force. So the force is going to be 109.43 newtons. So this is the minimum force that we are supposed to apply to this if it was to start sliding up. If we apply this force exactly, this thing will not move. But any slight up force we apply, even 109.44, we just change this, is going to start moving up. So that is what happened then. We have already overcome the static friction. Alright. So we've been given another problem here. Two masses are held together by a massless string as shown, assuming there is no friction between the box and the floor. So let's get this as the floor. So there is no friction. We want to determine the acceleration of the system. So the first one, what will be the acceleration of the system? So let's first consider motion. Because we've got this mass which is here, that means this thing will be moving downwards. So let's consider this as the direction of the acceleration. So this thing, remember, it has got a weight. Now in this rope there is tension. This tension is going to be reducing the movement of this thing downwards. And then in the other rope there is tension. So this tension is what will be pulling this thing upwards. So always to anything that is on an incline, there is Fg acting. So let's start first with this mass which is here. So the net force, it doesn't have any force in the x, so it is just moving in the y. So the net force in the y is given by what is pulling it downwards is mass times gravity, that is the weight, and then minus what is pulling it up is the tension. So the net force in the y is mass times acceleration, that will be equal to mg minus tension. The mass is 30, we don't know the acceleration, and that will be equal to the mass 30 and then 9.8 minus t. Okay, so that will give us 30A is equal to, if we multiply 30 by 9.8, okay, so 30 by 9.8, what I'm finding is 294 minus t. So let me take this t the other side, so that I bring this this side. So that will give me t is equal to 294 minus 30a. This will be our first equation. Now let's work with this one, the mass which is on the incline there. So the direction of motion, remember, is this one. So the net force, which now for that one is acting in the x, the net force in the x will be given by the one which is pulling it up is the tension force in the rope, and then Fg is reducing the motion. So the net force is given by mass times the acceleration, and that will be equal to tension minus Fg, which is given by mg sine theta. So the mass is 15, acceleration is a, the tension t minus mass, which is 15, the g is 9.8, and then sine, the angle of incline is 30 degrees. So this will give us 15a is equal to t minus, so we've got 15 times 9.8 also times sine 30. So that is giving us a value of 73.5. So if I make t the subject of the formula, I'm going to take that side, so that will leave me with t is equal to 15a plus 73.5. So we have got now a second equation. We can now solve these two equations simultaneously. So that will be 294 minus 30a. So since t is equal to t, then these others should be the same. So this we equate it to that. So 294 minus 30a should be equal to 15a plus 73.5. So let me take that side. Okay, let me do it the other way around. Let me take the 30, which is negative this side, so that I take this value the other side. So we're going to have 294 minus 73.5. So what will be this side is 220.5, and that will be equal to this 30. If it goes the other side, it becomes positive, and it will add to the 15, so that will be 45a. So therefore A is going to be equal to 220.5 divided by 45, which will be equal to 4.9 meters per second squared. That will be the acceleration. What of the tension? We can get one of these equations to find the tension. So the tension is going to be equal to 294 minus 30 times the acceleration, which we found as 4.9. So that will be 294 minus 30 times 4.9. So the tension therefore is going to be 147 newtons. Now the other one, we've been told if the coefficient of kinetic friction is 0.21, what will be the acceleration of the system if we've been given a friction? Because in this one we assumed there was no friction. So if we've been given the friction, that means there will be a reduction in motion. The speed is going to reduce, and so the acceleration is going to reduce. So friction always opposes motion. Remember, motion is going down, but the friction is on the incline, so there is mu k here. So this is going to push motion to the other direction, the opposite direction to the flow of motion or to the movement of the system. So in this case, if we start with this mass which is here, the net force in the x is going to be given by what is putting it in the forward direction towards the acceleration is the tension, then minus what is putting it in the back is Fk and also Fg. We can see that these are the arrows are pointing in the opposite direction. So this will be given by mass times the acceleration is equal to tension minus Fk is found by mu k times normal force. Now the normal force is mg cos theta, and then Fg is given by mg sine theta. Okay, so notice that all the masses are going to cancel out. So the acceleration therefore is going to be equal to tension minus our mu k, which is has been given as 0.21, g is 9.8, and then cos the angle is 30 degrees, then minus our d, which is 9.8, sine the angle, which is 30 degrees. So the acceleration is going to be tension minus 0.21 multiplied by 9.8 multiplied by cos 30. So what I'm finding here is 1.782, then minus 9.8 sine 30, that is giving me 4.9. So what I'm finding is acceleration is equal to tension minus negative 1.782 minus 49. So that is giving me a value of 6.682. So this will be the first equation then. So to find the other equation, we go to this other mass. Now to that other mass, the same equation which we used earlier is going to apply to that one. So the net force in Vy is going to be given by the weight, which is mg, minus the tension. So there's no friction affecting this because it is not on the incline, it's just attached on that point. Okay, the force making it to go downwards is the weight, and then the tension is reducing motion, that's why we are subtracting. So the net force will be mass times the acceleration, that will be equal to mg minus tension. The mass is a 30 times the acceleration, that will be equal to, here it is 30 times 9.8, which will give 294 minus t. Okay, so I can make t the subject of the formula so that I take t the other side. So that will give me t, and then this I'll take the other side. So t is going to be equal to 294 minus 30a. So in this equation where I see t, I'm going to replace 294 minus 30a. So that will be equal to a is equal to, where there was t, I put 294 minus 30a and then minus 6.682. So I can take this the other side so that it adds to the a. That will give me 31a, and that will be equal to 294. 294, we are going to remove 6. Okay, that is 6.682. 6.682. So the value that I'm finding there is 287.318. So to remain with the acceleration, I'm going to divide by 31. So the acceleration is going to be 9.268 meters per second squared. Alright, so that will be the acceleration of the system in this case. Okay, so now the other one we've been asked is to we've just been told to determine the acceleration of the system. So at they asked for the tension, we could find the tension just by getting one of the equations. We can even get this equation where there is acceleration. We'll just substitute the value that we have found, and then you'll be able to determine the tension. Alright, thank you so much for having watched this video. Hope it was helpful and have a blessed day.